Hi, Mrs. Torres. This is my Chapter 4 Test Corrections. For the first problem, we have rewrite this equation as an integral. And for these types of problems, what you're going to do is you're going to use this equation of limit as n approaches infinity, sigma n I equals 1, f of x times the change of x. And from this f of x, we expand where it's f of a, like x equals a plus change of x, I. So using this equation, we look back to our original, and the parts that we see from here to here that connect are this f over n is the same as this change of x, which goes with our other equation that we're going to use, which is b minus a over n equals change of x. So from here we have b minus a over n, and then we can plug in that this is 4 over n. And then back to this part where we have 3, and then this part here is the same as this a plus change of x, I. So when we look back here, a is this 2 here, and then this is the 4 over n is the change of x, which is the same as over here, times n, and then all of this is squared. So what you take for the a here, they give you that it's 2, so you can plug in b minus 2 over n equals 4 over n. And then from here we can cancel out these n's. So then we find that b equals 6. So now we have what b is, and we also have what a is. So now we know what we can plug in for this part, which is b and a. And then back to this equation, the main equation that you're going to use as you rewrite it is going to be 3 minus, and then this part here is the same as this f of x, so this part is the x inside. So x, and then since there's a squared here, x squared is going to be the main equation that we use. So when we rewrite it, the integral that we use is 6 to 2, and then the f of x we have here is this equation, 3 minus x squared, and then we just bring back the d of x since it's an integral. And then that's your answer. The next problem we have is a 15-foot ladder is leaning against a wall and begins to slide down. The ladder is moving away from the building at a constant rate of 1/3 foot per second. Find the rate in feet per second at which the ladder is sliding down when the ladder is 9 feet from the building. So for this problem, we're going to start out by drawing a picture so that we can visually see what is happening. So we'll just start with, this is the wall, this is the ground, and then this is the ladder. And since it says that the ladder is 15 feet, we know that the hypotenuse is 15 feet, and then this one is constant since the ladder won't be changing size or length. And then we can just put variables for what the wall and the floor are. And then we know that these two are going to be changing, so we can write this as x prime, which in the original equation it says that the ladder is moving away from the building at a constant rate of 1/3 foot per second. So this ladder is moving away that way. This is changing at 1/3. And then from here we can just write it as Pythagorean theorem. So x squared plus y squared equals 15 squared. And then to find the change, we'll just take the derivative. So then this 2 will go forward and we'll get 2x, x prime plus 2y, y prime, since we don't know those values yet. Or we're going to plug in those values. And then this just goes and is 0. From here, we'll just plug in the answers that we are given. which is, it says that the ladder is 9 feet from the building, so we know that this x, when this started, is 9, and then x changing is 1/3. And then we have to find what y is. So now that we know that this is 9, we can use Pythagorean theorem to find what this is. So y squared plus 9 squared equals 15 squared. And then we have 81 plus y squared equals 225. And then when you subtract this, y squared is going to equal 144. And then square root y equals 12. So now we found what y is, which is the original length of the wall to the ladder. So we can plug back here 12, and then we're going to be finding the y prime, like how much y is changing, or the rate at which the ladder is sliding down the wall. This all equals 0, and then when you solve for these, you get 6 plus 24y prime equals 0. So then 24y prime equals -6, because you subtract that over and then just divide, and y prime gives you -1/4. And that is the rate at which the ladder is sliding down the wall. For this problem, we have let velocity at this equation be the velocity of a particle moving along the x-axis for time t, which is in seconds, and then t is always going to be positive. When t is 0, the particle is at x equals -4. So then part A of this question says determine the position of the particle at time t. So then for this one, we're gonna, since velocity is the derivative of position, we're gonna do the antiderivative to get the position formula. So then since we have this equation for velocity, it's gonna be antiderivative 3t squared minus 12t. And then this is dt. And then we're going to power up so that this will change to the position formula. And then we power up, so plus 1. So it's going to be 3t3 over the exponent subtracted by 12t plus 1, which is going to be squared over 2.